I'm going to go from radians to degrees, I guess, in this. So 3 pi over 2 times 180 over pi. The pi simplify. So they're going to simplify. They're going to do 3 times 180 divided by 2, or 3 times 90. 3 and that there cut in half is 90. That's going to give me 270 degrees. For b, 7 pi over 6 times 180 over pi. 180 over pi. The pi simplify. So 7 times 180 divided by 6. Well, 180 divided by 6, I think, is 30. So 7 times 30 is 210. 210 for part B. 210 degrees. My answer is going to be negative 7 pi over 12. Once again, I multiply it by 180 over pi. The pi's will simplify. Well, if 180 divided by 6 is 30, 180 divided by 12, I don't know. I might have to use the calculator on that one. 180 divided by 12 is going to give me 15. So that's going to be negative 7 times 15 because the pi's cancel out. 7 times 15 is 105. So my answer is going to be negative 105 degrees. Times 180 over pi. 180 divided by 9, that equals 20 degrees. 74, determine which quadrant it is. So all students take calculus type stuff. All students take calculus. Where sine is negative, well, they're all positive here, sine is positive here. So sine is negative down here in the bottom. And cosine is negative over here on the right, on the left. So where they both overlap is in quadrant 1, 2, 3. So that's quadrant 3. Where sine is positive, so sine is going to be positive in the top. All students, so all are positive, sine is positive, so, and cosine is negative. Cosine is negative over here on the left, because sine and tangent are positive there. So the area of double overlap is going to be quadrant 2, here, where they're both fulfill those requirements. So quadrant 2. Sorry, I should have put II here. 75, limit as x approaches 2. So I take the 2, where it's less than, I throw it in there, so that's going to be 0. So that equals 0. And then I throw it in there, and it's 2 minus 2, that equals 0. So when they are both the same, that's the limit. So the limit of x of f of x, where f of x equals this, as x approaches 2, is going to equal 0. That's only true if they're the same. 76, 1 from the right. 1 from the right. I might want to graph this, but if I throw in 1, that's going to be the square root of 0, which is 0. And I throw in 1, that gives me 2, so they're not equal. So I actually have to do the limit from the right-handed side. So if I draw a quick graph of this, that's vertex starting point at 1, 0, and it goes to the left. That's what that graph looks like. And then this one is x plus 1. So it starts at 1, goes up 1 over 1, open circle, up 1 over 1, up 1 over 1. Notice it's a jump discontinuity at x equals 1. Notice this one was 0, and this one was 2, but it's not equal to 2 because there's no line under it. And now it's a right-sided limit because that's a little plus sign up there. So as I approach 1 from the right, my answer is getting closer and closer to 2. So this answer is 2. Even though it doesn't exist at 2, it's just what is it getting close to? It's getting close to y value 2. Now if that were a left-handed limit, if I read that wrong and that were 1 with a little negative up there at the exponent spot, it would have been this here, y value 0. But I believe that's a positive. 77, it's not a one-sided limit, it's from both sides. So I plug the 1 in, that gives me 1 plus 1, which is 2. This limit is 2. I plug the 1 in, 1 plus 1 is 2, half of 2 is 1. This is the wonderful, the limit does not exist because they don't equal one another. If you ever saw Mean Girls, that's what she meant. Difference quotient. I'm going to take this template, I'm going to draw a big division bar. I'm going to put a minus sign on top of that division bar for this minus sign here. Then I'm going to put H for this H underneath of it. Then I'm going to take that f of x, see how f of x is in the back end? I put f of x back there. Whoop, I'm not going to put f of x there. I'm going to put 8x minus 11. I'm going to wrap it because I have to distribute that negative. Now this is what's tricky. I don't put 8x minus 11 in front. I put 8 times some quantity minus 11. And I have to figure out what that quantity is. What quantity do I put in for x? And notice, the quantity I put in is x plus h. Now I have a lot of petty algebra to do. I have to distribute, and then simplify. So let's see what this is going to equal. So this is going to equal 8x, big division bar, oops, sorry about that, big division bar, all over h, but it's going to be 8x plus 8h minus 11 minus 8. And this is the biggest mistake made, is distributing this negative, minus 8x plus 11. Now I have to do some simplification. Notice the 8x and the negative 8x simplify. Also notice the negative 11 and the positive 11 simplify. That is going to give me 8h plus 11. I'm sorry, that's going to give me 8h over h. And that equals, lo and behold, just 8. That's the difference quotient. Now I'm going to do difference quotient for part B, and this one's a whopper. I might even move that over to the next page. So let me move that difference quotient over to the next page so I can work on it alone. Okay, here we go. So I'm going to do the big division bar with the minus sign, for that minus sign there, all over h, big parentheses. Now ask yourself, what does f of x equal? And f of x in this case equals this quantity, x squared minus 13x plus 5. Now what I put up front, wherever there's an x, I leave an open parentheses. So x squared minus 13x, I leave it open, plus 5. Now I have to determine what goes in this spot here and this spot here. And that isn't f of x, that's x is replaced with x plus h. So I have to put an x plus h here and x plus h here. I have a lot of petty algebra to do now. Big division bar. All over h. Now I have to square that. X plus h squared. Let's see what that is if I FOIL it out. X plus h times x plus h. A lot of people think it's just x squared plus h squared, but they forget I have to put an xh here, or hx, I don't know, I'll put xh. Now I should put hx, hx, hx. How many hx's are there? There are 2. So when I FOIL this out, it's going to be x squared plus. This one's part B. I'm going to need my big division bar. All over h with a minus sign. And now I'm going to put big parentheses in the back because f of x this time is equal to this long trinomial. X squared minus 13x plus 5. Now what goes in front is kind of difficult. Wherever there's an x value, I'm going to leave it as a parenthesis. So this is going to be parentheses squared, x squared minus 13 times x plus 5. And I have to determine what goes in this spot here for where the x was. I can't just put an x in there. This time x is replaced with x plus h. And now I have a lot of petty algebra to do. First I have to do is FOIL that x plus h squared. It's all over h still, but I have to FOIL x plus h squared. A lot of people think that x plus h times x plus h is h squared plus x squared, x plus h times x plus h. They just think it's, oh, that's just going to be x squared plus h squared, because h times h is h squared. There's also an hx and an hx. So I get 2 hx in the middle. So when I FOIL that out, it's going to be x squared plus 2hx plus h squared minus 13x minus 13h plus 5 minus x squared plus 13x, getting a little long, minus 5. A lot of simplifying to do, but it should go pretty rapidly. I like to work from the back end. What simplifies with negative 5? Positive 5. What simplifies with 13x? Negative 13x. And what simplifies with negative x squared? Positive x squared. So let's see what's left over after I do all those simplifications. I don't need such a big division bar anymore, do I? I have 2hx plus h squared minus 13h all over h. I call this muchos hachas, a lot of h's. Notice I can factor an h out of the top. So I'm going to do my big division bar. I'm going to factor an h out of the top. That's going to give me an h times 2x plus h minus 13. Notice if I were all over h, if I were to distribute that h, I would get back to this. Notice the h's simplify. So my final answer for this difference quotient is going to be 2x plus h minus 13. More limits as x goes to 4 for this one. So for part A, it's just going to be the square root of 4 plus 2, which equals the square root of 6. It's just algebraic. You plug it in, that's the limit. For part B, I plug in 4, it's y goes to 4, so it's going to be 3 times 4 minus 1. The absolute value of 3 is 3. 3 times 3 equals 9. This one, too, when I plug that in, it's a little troublesome. When I plug in the 2, I get 0 over 0. So I'm going to take that one to a different board, and we'll do that limit individually. So notice when I plug in 2, I get 0 over 0. And that's considered indeterminate form. So all I have to do is factor this. And notice when I factor that, the 2's cancel out. So the limit, as t approaches 2 of, that's a t by the way, of 1 over t plus 2 can now be found. When I plug that 2 in there, is going to equal 1 over 2 plus 2, which is 1/4. Not that harrowing. Part D is probably going to be the same thing. I'm going to get 0 over 0. So I'm going to take that to its own page. I'm going to do a little factoring. First thing you want to do is plug in the 3. That's going to give me 9 minus 9. That equals 0. Whoops. Over 0. Because 3 minus 3 is 0. Now whenever it's 0 over 0, you have to factor. So that's going to be t plus 3 times t minus 3 all over t minus 3. Notice the t minus 3s are going to cancel out. So the limit as t approaches 3 of t plus 3 is going to equal 6. I just plug that 3 in and it gives me the answer. 3 plus 3 is 6. E, getting a little bit more involved. Let's see what happens when I plug 4 in. When I plug 4 in, I get square root of 4 is 2. 2 minus 2 is 0. When I plug 4 in, I get 0. So this one's really challenging because I have that radical. I can factor the bottom, but that's not going to cancel anything out. So what I have to do is unrationalize this. I know you've been used to rationalizing, but now in calculus, we have to unrationalize in certain instances. When I FOIL the top, I get t minus 4 all over. Now I'm going to factor this, t plus 4, t minus 4, times the square root of t plus 2. And the trick is to not simplify this, is just to factor it. And we'll notice that this t minus 4 cancels out with this t minus 4. So I'm going to have 1 over t plus 4 times the square root of t plus 2. And that's my new limit as t approaches 4. Let's plug 4 into this. What's 4 plus 4? That's 8. What's the square root of 4? That's 2 plus 2. So it's going to be 8 times 4. My answer is going to be 1 over 32. I have to unrationalize the numerator. A cubic. So let's see what happens with this one. I bet when I plug 2 in, I get 0 over 0. Notice when you plug 2 in, you get 8 minus 8, which is 0. I plug 2 in, I get 4 minus 4, which is 0. So I'm going to have to factor it. Factoring the cube is going to be a soapy problem. This is actually 2 cubed. So it's going to be same, opposite, always positive. X and 2 go in here, X and 2 go in there, and then X times X is X squared goes here, 2X goes in the middle, and 2 times 2, 4 goes in the right, all over. X minus 2 times X plus 2, you factor this, those cancel out. Now let's plug 2 in, that gives me 4 plus 4 plus 4, or 12 over 2 plus 2, 4, is actually equal to 3. There's another way to do this with an H hat called L'Hopital, but we'll save that for later. Another one I have to factor, but it's a left-handed limit. I plug in 2, I'm probably going to get, oh wait, that's negative 2. 4, 8 minus 2 plus 1 over 0. Ah, that's D&E. Don't need to factor it. I'm good. Who cares if it's approaching from the left? No, it's probably a hole there. It's probably a hole. Have to graph it. Have to graph it to make sure. D&E is okay, but it's the left-sided limit. So 2x squared plus 1x plus 1. I'm going to put the coefficient of 1 there, and then 2 here, and the factor is going to be 1 times 2. In order for that to reach 1, it has to be negative 1 and positive 2. I'm just factoring. So the factors at the top are going to be 2x minus 1, and the bottom is going to be x plus 1, all over x plus 2. Have a vertical asymptote at x equals negative 2. I have a horizontal asymptote of y equals 2. I'm going to plug in a value here, negative 3. I'm going to plug in a value of 1. I can plug in a value of 0. That would be more convenient. So when I plug in 0, I get 1/2. That lets me know the graph is going to come like this. When I plug in 0, I get 1/2. Then let's see what I get over here. If I set the top equal to 0, I get negative 1 and 1/2. That's okay. Oy. The deal is when I plug in negative 3, the graph is going to look like this. So, as I approach negative 2 from the left, it rises up, and the limit is going to be positive infinity. So positive infinity is the answer to this limit question. A little tough. H. We already factored that one, but it's 2 to the third, and that's a SOAP. Meaning same, opposite, and then always positive. Same, opposite, always positive. And this is basically x cubed plus 2 cubed, so the x and the 2 go here. Then I square the x. Then I do 2 times x. Then I square the 2. That's on the bottom. Top is going to be x plus 2 times x minus 2. I'm sorry I didn't plug in negative 2, but if I did, I get 0 over 0. So that means you have to factor. Now since these cancel out, I can plug in negative 2. Negative 2 minus 2 is negative 4 over 4 plus 4 plus 4. That's going to give me negative 4 over 12, and that equals negative 1/3 is the limit. I. A lot of limits. Limits at infinity. You can factor this if you want, but you really don't have to. Basically, you're going to look at the horizontal asymptote. So if this were algebra 2, what's the horizontal asymptote? Well, the degree of the top is smaller than the degree of the bottom. So the horizontal asymptote is going to be y equals 0. And that means when you graph this, as x goes to positive infinity, whatever the graph is going to approach y equals 0. Not that big of a deal. You also could have done it just by looking at the largest exponent in the top and the largest exponent in the bottom. So it's going to be 3 times infinity squared over infinity cubed. And this simplifies to 3 over infinity. And as these numbers get bigger and bigger and bigger, this approaches 0. So that's another way of looking at it algebraically. So the answer to this is 0. Another one at infinity, x squared over x squared. So negative x squared over negative x squared, that's actually going to approach 1. Because the horizontal asymptote is y equals negative 1, I'm sorry. So the limit that approaches infinity is negative 1. This is not going to have a horizontal asymptote, it's bigger on the top, so that's going to be an oblique. So that's going to approach infinity. Because basically we get 1/4 x over nothing. And that infinity goes in for x, and that's going to be infinity over 4. And infinity divided by 4 equals infinity. Is that negative infinity? Then it would be negative infinity if I put a negative there. This one, horizontal asymptote, is going to be negative 1/4. You can do it that quickly. That was that one. Last one is h. Let's see what that one looks like. When I plug in negative 2, it's going to be 0 over 0. I think we've already done this one. H-I-J-K-L. Okay, I need m and n. As it goes to infinity, this is going to be negative 3 x squared over 1. When I plug infinity into that, that gives me negative 3 times infinity over 1. So it's going to be negative infinity is the answer for this limit. This limit, the degree of the top is smaller than the degree of the bottom, so it's going to be y equals 0. No matter what you plug it in, it's going to be y. So this limit is, as it approaches negative infinity, is going to be y equals 0.